In this video, we'll learn how to use the Rossmann-Chance applet in order to do a hypothesis test using a theory-based approach. Please note there is another video accompanying this where we go through this process using simulation as well as showing how to basically solve it with formulas by hand. Okay, so in this problem, we have a cookie company. They're claiming that their cookies have an average, a mean, of 24 chocolate chips per cookie with a standard deviation of 3.1 chips. I go out, I randomly sample 40 cookies, and my sample has a mean of 19.6 chocolate chips per cookie and a sample standard deviation of 3.8 chips. We are testing the null hypothesis of there being mean of 24 chips per cookie in the set of all cookies versus the mean of all cookies not being 24 chips per cookie. Just real briefly from the previous video, we had already worked out the fact that the distribution of sample means, whether you use simulation or a theory-based approach, will be roughly normally distributed. And we said that we do meet the validity conditions for using a theory approach because our sample size was more than 20. I have bulleted here some of the things we discussed in the previous video, that when we did the formula, our standard error was 0.49. We calculated a t statistic of t equals negative 8.9, and we concluded that we had support for the alternative hypothesis. Okay. We're going to find the same thing here, but in this video, we're going to really do everything with the applet, the Rossmann-Chance applet. So before you dive into using an applet to solve this, it is important that you always first make sure you're really clear on the given information in the problem. So in this problem, we've been given information about the hypothesized value of the population mean, as well as the population standard deviation as given by the cookie company. So in this case, we were told that the hypothesized value of the population mean is 24 chips per cookie, and the cookie company also said that their population standard deviation was 3.1 chips per cookie. I want to just recognize having a standard deviation of the entire population would be a weird thing to have if you are really not even sure of the true value of the population mean. So this is kind of one of these math problems that is coming up in a math class, but doesn't really make a lot of sense in reality. So I just want to just point that out. The other given information in this problem was information about our sample. So in this case, in our sample, we sampled 40 cookies, so n is equal to 40, that's the sample size. Our sample mean, x bar, was 19.6, and our sample standard deviation, s, was 3.8. Make sure that you really clearly identify all those little pieces for yourself before you dive into the applet. In order to use the applet on Rossmann-Chance, we go to the main Rossmann-Chance applet page, and we're going to select the theory-based inference applet. You'll see that that's over here on the right-hand side at the bottom, theory-based inference. And I think this one is pretty self-explanatory. So over on the left-hand side, working top to bottom, on the pull-down menu, you need to first figure out what type of problem we're working with. We're working with a distribution of sample means in this problem. So we select one mean. And then if you actually have the raw data from your sample, you can check this box and paste that in here. In our case, we don't have the raw data. We have information about the statistics from that data, and we just put those in. So our sample size n was 40, our sample mean x bar was 19.6, and our sample standard deviation s was 3.8. We hit calculate, and it comes over here, and it creates this little graph here, but I'm not as interested in that. I want to make sure I go over here to the far right side where it says theory-based inference, and right now we're doing a test of significance, a hypothesis test. I select that box, and now I tell the Rossmann-Chance applet my null and alternative hypothesis. So in this case, our null hypothesis was that mu is equal to 24. Our alternative hypothesis, I select this little box here, and notice you can scroll through until it's less than, greater than, or not equal to, and we are doing not equal to 24. And then you select calculate. It draws the distribution of sample means, the distribution of sample statistics. It also puts a little bar, a little blue vertical bar at the location of your sample statistics. So notice mine is on the very far left side of this graph, representing the value x bar equals 19.6. It's extremely far to the left, as we learned in the last video. That remember, this had a t-score of like -9. It was 9 standard deviations below the hypothesized value of the mean. And in this case, since we're doing a two-sided test, it will put the equivalent distance vertical bar on the right-hand side. And if you scroll down a little bit, you can then get those important values that help you make your actual conclusion in your hypothesis test. It will give you first the standardized statistic, which is the t equals -7.32. And it will give you the p-value, which in this case is 0. It's going out to 4 decimal places, and so it's extremely small p-value in reality, and it's rounding to 4 decimal places. The p-value is 0. So again, we would conclude that we have statistically significant evidence in support of the alternative hypothesis. We support the idea that the number of chocolate chips on average is not 24 chips per cookie. There's one last thing I want to point out here. In the previous video, we had calculated the standard error, the standard deviation of our distribution of sample statistics. And in that calculation, we used sigma, the given standard deviation of the population, which again is something that is not usual to actually have in reality. The Rossmann chance theory-based applet is getting a different value for the t-score because it is using the s in that calculation. It is not using sigma. Notice nowhere in here did I actually put in sigma. It's using the formula s over square root of n, which is, in this case, 3.8 over square root of 40. If you pop that in the Desmos calculator, you see that that standard error comes out to about 0.6, which is different than what we got in the previous video when we used sigma divided by square root of n, and we got approximately 0.5 for the standard error. So when using sigma over square root of n, we got about 0.5 for the standard error, which in turn gave a t-score of about -8.9. Now, when we find our standard error with s over square root of n, you will notice that our t-score comes out to about -7.3. Our sample statistic minus the mean of the distribution, all divided by that standard error of 0.6, comes out to about -7.3. Different than what we got in the previous video when we got a t equals -8.9. However, if you use that s over square root of n in the formula, and then you calculate your t-score and get -7.3, you will see that that matches up with what is given in the applet, t equals -7.32. So please make note of that. The applet is using s over square root of n for the distribution of this sample means.